In this video, we are going to talk about DNA fingerprinting and how it can be used to solve crimes. During this pandemic, most people try to make less trips to the grocery store unless they need something essential. That's why it was such a big deal to the Smith family when the last cookies unexpectedly went missing from the cookie jar one night. Riley Smith claims to have witnessed the family dog Scotty eat the cookies. This is his photo evidence. However, his sisters Sydney and Megan are not convinced. Their dad Mark examined the empty jar closely and found a strand of hair stuck to the outside of the jar. One of their family friends is a forensic scientist, so they sent him the evidence and strands of their own hair to compare it to. To identify the culprit, the forensic scientist is using VNTR repeats to create a DNA fingerprint. VNTR stands for Variable Number of Tandem Repeats, which means that sequences of bases are repeated over and over again. This technique is efficient because different people have a different number of base repeats. The repeating units are separated by weight using gel electrophoresis. Here are the results. The forensic scientist ran 2 different gels because he tested 2 different loci. It is important to test multiple loci because you don't want to convict the wrong person. We can use both gels to identify the culprit. So looking at gel 1, we want to match the bands at locus 1 with the bands of some of our suspects. So starting with the first band, we can see that Riley, Megan, and Mark have matching bands. The second band, Scotty, Riley, and Megan match. So looking at our results, we can see that both Riley and Megan matched the hair at locus 1. At locus 2, following our bands across, we see that we have matches with Riley, Sydney, and Mark. At the second band, we have matches at Riley, Megan, and Mark. Looking at this data, we see that both Riley and Mark match the DNA at hair locus 2. So, from this, we can conclude that Riley is the culprit because he matches the DNA at both loci. Even though most of the suspects are related, they still have different bands because each person has different length repeats. Additionally, you can distinguish between parents and their offspring because you get half of your genetic material from each parent. Therefore, you will have similarities to each parent, but you will not have identical DNA samples to either parent. This is illustrated in Mark and his children because in each gel, he shares one band with each of his children. So in this first gel, Mark shares his top band with Megan and Riley, and the bottom band with Sydney. Again, it is important to test multiple loci because as we can see, both Riley and Megan matched the evidence in the first loci, so we needed the second loci to identify Riley as the culprit because the DNA must match at all loci. Without multiple loci, the wrong person could accidentally be convicted, and it is especially important to not do this when solving very serious crimes.